So good afternoon, everyone. So today I'm going to talk about malware detection and prevention using CESS. So to give you first, I will give you a brief on CESS. We talked about CESS in the previous workshop in the series 1. So in this session, we'll talk about the result of CESS that we have deployed. So to give you the overview, CESS is short for Cloud-Enabled Security Services. It is a security as a service. Okay, so we talk about infrastructure as a service, software as a service. So similar to that, this is security as a service. So CESS allows the provider to host network security and monitoring services in a cloud. Okay, so because this will be the cloud-based system, so the expectation is that it will be cost effective. We can scale it very easily. It will require less maintenance because it is centralized, and it can also replace some of the on-premise appliances that we use for security. So this is the architecture that we proposed for CESS. So in here, this is the CESS Central. Then it will be connected to the internet. And through that, multiple entities can be connected to the CESS. So because we are working with the NRANs, like MyRANs, IDRAN for Philippine, I think it's PGNet. So all the universities in those networks that are connected to the NRANs, that will be connected to the CESS. Okay, so that was the basic idea. So we propose that CESS will be installed in the NRAN, so that the entities that are universities or education institutions that are connected to the NRAN will get the security services by default. So for DCNDS, so this was our idea. So because of the shortage of funding, so can you see the ledger when I move? Okay, thank you. So because of the funding issue, so we proposed to set it up as a case study in BDRAN. Okay, so CESS will be set up in BDRAN, and we have other module I think we talked about in other lectures. The distributed Botnet monitoring nodes, it will be installed in all the NRANs. So accordingly we set up CESS in our BDRAN, that is Bangladesh RAN. So this was the idea then, and we followed it up. We designed the whole thing, and so we'll talk about in the next part how we install it and what data we have received from the system in the last 6-7 months. So for the system, we chose Cisco Web Service Security Appliance, or WSA. The model was 600V. So we set it up in Cisco Async OS as a virtualized environment. It was for the virtual system, we used VMware ESXi, and the disk size was 1 terabyte, and we had initially 24 gigabytes of memory in that particular device, in the particular VM. And it was deployed in the BDRAN cloud in the first installation. So for setting it up, after the procurement, we designed a low-level diagram for how the network traffic will be diverted through this CESS system. Then we installed the Async OS in the VM. We got the license key for the WSA. So we obtained a 3-year license under this project for the WSA. And we configured it in a transparent deployment mode, and so that the traffic can be passed through without any issue. So initially, for our testing, we only redirected the BDRAN server traffic, the HTTP and HTTPS traffic through this system. We didn't redirect all the traffic because of the limitation of the hardware. Because this EBDN has over 70 education institutes connected, and it had the bandwidth is several gigabytes. So it was a problem for us initially. So this was the network architecture. So ideally, the CESS was supposed to be installed in as per design. It was supposed to install before the router, so that all the traffic can pass through. But the problem was that BDN already has the data center that is out here on the right side. So, and data center is already set up in that way. And we had to use their data center for setting it up. So we install CESS in that data center. So the problem that we face is that because it goes through the core router and the core switch, so in this region, there is twice the load because the traffic goes once and traffic goes back to the POP router. So that is one of the challenges that we face during the installation. So there are several challenges that we faced before the deployment. So the low-level diagram was not ready, so we had to prepare those. And the diversion of web traffic, as I said, because it will create high traffic volume. So because it was in a separate already, the data center was set up in a different location through the switch. So we had to design accordingly. And also we found out that the router requires the WCCP support in the end device so that the traffic can be diverted. So that was also a problem because some of the devices in the network did not support the WCCP. So, but we overcome those. Then after the deployment, we had several months, we had several issues after the deployment. So one of the main issue that we found was that the software of the system, WSS system, repeatedly hanged, became irresponsive. So we had to dig it out, what happened, why it's happening. So Cisco was involved. Cisco tech team, the technical team was involved. So it took us, I think, over 3 months to solve all the cases. And after that, we were able to set up the system according to our requirements. So let's go into the data part. So first, this is overall statistics. So average transaction that went through the CESS system was 223.73 per second and 23.5 megabytes per day in terms of transactions. So maximum transaction we received was 730 per second and 49.1 mega per day. Average bandwidth used was 27 Mbps and maximum bandwidth was 1.2 Gbps. Average number of connections at a time was over 6,000. And during attack scenarios, we'll talk about it later, we got a maximum connection of 33,000 at the same time, concurrent connections. And we got over 270,000 unique users in terms of IP addresses that pass through this CESS system. So in terms of top user, that bandwidth was used was most 4 was from Germany, then France. Then we have 3 from Germany. Then there were 1 from US, Japan, and Russia. So bandwidth is basically it maps to attacks as well, because when they attack, so that there is more concurrent connections, and that means it also use additional bandwidth during that time. So in terms of transactions, again, similar patterns is there. So we have top three, we have 20 million transactions from some IPs. Also, we have some, in the lower part, we have close to 1 million transactions. So to go to, before analyzing the attacks, how we got those. So one important thing is how we actually configured the system. So there's a concept called web reputation filter. So a site is assigned a reputation score based on several properties: domain owner, hosting servers, the time the site was created, the type of the site. So all this is taken into account, and based on the score is between -10 to +10. So based on this score, we can configure whether we want the traffic to be blocked or to be allowed or to be delivered with warning. Okay, so that is configurable. So in our case, what we did, so as I said, the score is between -10 to +10. So we set it up like this. So if the score is less than -6, so we block the traffic by default, so it will not go through the system. And on the other hand, if the traffic is greater than 6, so we allow that traffic by default, assuming this is a good traffic, so there is no further analysis is required. So in the middle, between -6 to +6, so we set it up so that the system will scan the traffic further. Then based on the scan result, it will either allow the traffic or block the traffic. So that's how we actually configured it. But you can configure it in a different way. You can change the threshold for scanning and blocked and allowed. Okay. So so this is the data. So now we'll go into the details of the data that we analyzed. So this is started from October because, as I said, it took us some time to set it up after the procurement. So we started to get some data in September, but for the October, from the October, we get the data for the full month. So in October, we see there's 11.6% of blocked data, block percentage in terms of volume. Then 80% was scanned, but it was clean. There's only 0.05% that was clean and malware was detected. And 7.79% of the connections were allowed. So if you look at here, here almost 88% traffic were allowed, then only around 12% of the traffic were blocked by the system. So moving on to November, we see the attack goes up. So later on, you see there is actually attack on those months. So you see there is a block goes up to 33%. So the allowed traffic goes down a little bit. I think it's around 67%. So we see a spike in the block traffic. So block means there is attack going on, and system was able to block that attack from the users. In December, we see similar trend. So there is also similar 32% of blockage. Then in January, we see another rise in the block percentage. We see 48% block, and malware in total, it was over 49% that malware is detected and blocked. And so, so as you see, there's a spike from 32% to 49%, right? So we have additional attacks in January. Then in February, we again see a downward trend. So in this case, we see again only 10% of the traffic was blocked and 89% traffic was allowed. So that means if you, so that blocking is related to how many attacks are being launched in the system or against the system from outside. So based on the attack scenario, system can detect and block. So that is the observation that we have received from here. So if you look at the summary here, so if you look at the red marks, so we see the attack blocking percentage 11 to 33, 33 and 48 in January, and it goes down again in February to 10%. So in terms of millions web reputation actions, so if you look at the block percentage, so this is for the 5 months in a bar. So we see the traffic, as there's more traffic, so there is more blocks, and there is also allowed traffic is almost similar in terms of valid traffic. But when there is a rise in traffic, mostly the rise is because of the attack scenarios, and so resulting in higher blocks in the system. So this shows traffic trend in terms of days. So the x-axis is days from 1 to 31 days. So we're trying to show what happens, how many traffic is blocked in a particular day period in terms. So before we saw it for the whole month period. So as we can see, there is in January, we have a lot of blockage. So we can see on the 16 from 14 to I think 18, there is a large attack happened, causing the block to rise. And also there's another attack in January that happened between 22 and 24. Okay. If we look at December, we see there's an attack between 26 and 30. So there is a basically it's attack on I think 27 and 28. So it goes up, then it goes down, and the attack diminishes. So this shows us, so the attack does not happen every day. It happens in a period of 2-3 days, and then it goes out. So malware detected by scan. So this is for blocks. That means the reputation was below -6. So it was not scanned further. So by default, this traffic were blocked at the beginning. Now this is the suspicious traffic. So the score is between -6 to +6. So after scanning, we don't get too much as we saw before. So after traffic, we do not detect too much malware. Occasionally in January, we received a lot of malware after further analysis. If you look at the yellow part, this is for January. On the other hand, on the other months, we actually saw the after scanning further. Most of the traffic are actually passed through the system, but normally it's not blocked. In January, there is a tag that was not the reputation. That means the reputation was actually acceptable in the middle, but after further scanning, it was deemed that it has to be blocked because there is malware detected. So this is in terms of malware detected. So the y-axis is changing. So this is the volume is very high. I think it's over 120 million. And in this case, this is only, I think, 7 million, right? So this shows the allowed traffic for different cases. So for allowed traffic after the, by default, allowed traffic, that is the reputation is always greater than 6. So there is no real pattern here. If you look at here, you cannot say the traffic is always similar for a particular day. So as there's different So it depends on the traffic as well. So how many valid users are looking to going to the system or trying to use the system, and those comes into the scenario whether the traffic will be allowed or not. So this is the total traffic in terms of the all blocked, allowed, and suspicious. So as we can see, in February, we actually have a lot of traffic. So in October, we did not have much. So we see there is a spike in January, and there is also a spike in February. I think this is this shows, so as the traffic grows, so there is a pattern for more blockage and as well as more allowed traffic in the system. So this is all the total. So in this case, we are showing the total, I think pink color. So this is the total of all the traffic for blocks, scanned, scan further, clean, and allowed. So if you sum this all up, so this is for October. So as you can see, the traffic is much higher when the attack happens and during this period. So in that case, we see more blockage as well as more traffic. So this is like similar trend we see in November, in December. So whenever there is a more traffic, it normally means for this kind of system, because it's not, you know, for wide user base. So, but when there is a more high spike of traffic, so generally it means there is a attack going on, so resulting a block of traffic to the users. So we see a similar trend in January and February as well. So now I'd like to show you the reputation score that we found. So as I said, the reputation is between -10 to +10. So this is the region that traffic is blocked by default. So no further scan is done on those traffic. So reputation, if the reputation is very low, then the traffic will be blocked. And on the other side, this is +6 to 10. So in those cases, traffic is also allowed by default. And this is the middle scenario when the traffic is scanned further. And in most cases, as you can see, the traffic is passed as clean. Now, one interesting thing here is that even though we configured the system that after, if the reputation is over 6, it should be allowed by default. So we see some traffic were scanned despite that. So this is because what we understand from Cisco is that after passing that, so some same traffic, similar traffic that comes suspicious in later on. So when that traffic was suspicious and it was detected as malicious, so even though the reputation score was higher, so they send it to further scan because similar data was, malware is detected from similar IP address or similar zones. So that's why we see, even though there is a reputation score of like 9 or 10, still it is in some cases, these are further analyzed, and we see in some cases the traffic are actually blocked as well. Okay, so that was quite interesting to see. So we see similar trends in November, January, December, then January and February as well. So let's try to see the scan result. So this is the reputation score is between -6 to +6. So for devices, for different months. So the scan was started in October. We started with around 300 million. Then in January it goes up to 400 million. Then in February it was over 600 million, or I think 550 million. So what it means basically, as the traffic, as we saw, the traffic bandwidth usage of traffic goes up, that means more and more traffic will be in between that range of -6 to +6. So more traffic will actually be analyzed further for malware detection, which also means that the uses of the system will be higher in terms of malware detection and analysis, because when you pass through, there is no additional complexity, but when you scan, that means you have to decide whether there is a malware is there, and based on the scanning, then you have to decide whether you have to block it, and further future also you decide whether you block the future traffic from the same IP address or from the same servers. So let's look at the threat that we detect in our reputation filter. Okay, so we are saying we block those, but why we block those? So the most of the attack type we find is phishing, right? So you can see over 48 millions of traffic is phishing. Then there's also the malware sites that the attacks comes from. This malware sites is over 30, I think almost 33 millions. So these two are actually the most of the attacks that we received. This is for October. There is also attacks from malicious sites. So Cisco actually, the device that we use, they actually categorize these types of attacks when they block a transaction. So there is also a spam. Then also there is spyware or adware, not much. And we also received some botnet attacks as well, over 5,600. So this gives us an idea what type of attack a system can get when it is exposed to the internet. So if we look at further in November, we see similar trend, malware sites and phishing. Then in December, we also see similar trends. Also in this case, we see a lot of botnets in December. So it's over 600,000, which was very little in the previous months. So that was also a concern, how botnet was increasing as an attack type in the system. Then in January, we see a little bit different. So in January, we see a lot of malware site attacks, but phishing at all was much less compared to before. So here we see the attack from phishing, that here we see a lot that attack from malware sites. So later we identified, so this comes from different areas or different zones. So one type of attack that was launched, it came from Germany or in the Europe region, based on the IP address, and they used the malware sites. Others from the China, they more use the phishing ones. So in February 2020, we see similar trend. So we see a lot of malware sites, but less amount of phishing and other types. So if you compare over the 5-month period, we see the malware sites is a lot, and there is a huge spike in the January, because there is a huge attack went on like for 3-4 days using this type of attack. In terms of phishing, we see a rise for 3 months, but then we see it diminished, the phishing error diminished from January to February. In other cases, other type of attack, this is consistently similar. It's not too much, but it's always going on in terms of attack scenarios. So if we, in terms of malware size, so how many malware is blocked in terms of, if we look at the numbers, so we see for different months. So in January, there's an attack for malware site. We see there's 160 million was blocked in a particular day. So on the 17th of January. So as I said, there's attack going on between a long period of 5 days here. So as the attack was going on, so more transaction was blocked, and maximum in one day, the system blocked over 160 million attacks in a single day. So in terms of phishing, we see, as I said, the phishing happened basically in December. There's a large attack in December. So the attack happened in 3 days, I think. So in a one day, the maximum block was 160 million transactions. So that was also massive. And after that, we did not see too much phishing attacks on other days in other months as well. So this is for botnet. So for botnet, so this is, as I said before, so in January, we see a spike in botnet. So that's happened in the first couple of days. And we also see a spike in December in several areas, several days. But otherwise, it's very similar in terms of. So what the trend that we see here in different types of attacks, if you look at the graph for different days, so we see there is always a minimum type of minimum attacks going on every day on an average level. But in some cases, in some days over a period, there is a large attack comes in, and it goes on for 2-3 days, so causing a massive attack scenario. So that is the pattern we see for different attacks. So all the attacks does not come in the same day or in the same period. We do not also find out any scenario that it will always happen in a specific days of the month. If you look at the patterns, you do not see any pattern that it happening only in the first of the month or in the middle of the month. So it's completely random. It's very difficult to find any pattern that may be happening in there. So there is other other type of attack that was not blocked, but it was detected after further analysis. So we see different types of attacks. We see gambling sites. We see hacking attempt. We see illegal downloads from illegal sites like movie or other contents. We see pornography sites. We see weapon-related blocking, and also we see some child abusive content related attacks as well. So this is for October. We see similar trend in other months as well. So if you look further, if you look at malware that has been detected, so most of the malware were categorized by the system as other type of malware. So you cannot definitely say this is this type of malware. Apart from the other types, there is virus, over 5,000. There is also password attempt, PUA attack, and also there is attack using the encrypted files, that the encrypted file contain the malware. So we see this kind of malware categories. So we see similar trends in other months as well. So most of the cases, we see other type of malware being detected. But in February, after the 4 months, we see there is a large spike in terms of virus attack in the system. So in February, we do not see other type of malware. So in virus has the I think several millions in terms of attack scenarios. So this is day wise comparison in terms of in malware. So we see again. So this malware detect it is related to the attack type. So we see the rise here because the attack was going on during that period, and otherwise it's very close to average. So this is combined. So you see similar trends for malware in November and then December. So and February we see a different pattern. So in February there is an attack at the last of the month, and we see there is a virus attack. So in others up to 27, it's very close to normal scenarios. But after 7, we see a spike in virus attack that happened in the system. So this is the malware detected comparison over different months. So the idea for for this type of slide was we're trying to find out whether there is a pattern that whether that particular type of attack is repeated in the same period of the month. So as I said before, we did not find out any such pattern. So it's we think that it probably completely random. So the attackers do not attack the same system, or may not attack the same system over a period in the same day range over different months. So this is a comparison of virus detected in different months. So here as well, you do not really see any pattern that is going on in terms of detections. So this is virus detection. This is PUA. So PUA is not too much. So it's always some attempts is going on. So PUA is someone tries to, log in using the SSH or your server credentials. So tries to, repeatedly tries to break the password. So you see there is always some attacks going on, not too much, so 100 to 100. In some cases, there is occasional spikes, but we see similar patterns in every month. So there's always some attacks to break the password in different servers and different systems. So these are some of the malwares that we detected in the system. These are actually, the malware types. So the most type of malware that we detected was VBS inor. It was Visual Basic Script. So it creates more malware after it can regenerate. We see Trojan attacks. We see, so there's one attack is called Malgen. So it is one type of malware. So the top ones, these are the virus category. We see different names. And then in the malware categories, the name is given by the gen, mal.gen, then there is a suffix to identify which generation it is. So all these have some kind of malicious behavior, and those are detected in the system. So in most cases, I think we saw the IX is the most attacked malware type we see in the system. We see some of the coin miner for like Bitcoin mining type of attacks using PUA. And also we saw some unnamed malware there. So some of the malware that was not able to detect with any particular naming in the system. So if you look at the type of attack, so you see the Malgen IX, this is the most attack in terms of, so this is a malware, and we see 77% is in these scenarios, and we have 12% of VVS. This is a virus, VVS, and we saw some others as well. So this is for October. December, October to December. So this is for 3 months period. So we see 78% has Malgen IX again, and VVSC node. So these are the two most common. Then we have other types of attacks in other scenarios. So if you look at top in terms of daily trends, in terms of malware types, so we see spikes in different levels. So this is again Malgen IX. So we see Malgen IX in different periods of the day. But it also has, consistently there is some attacks going on. But for other cases, the virus attack, we see a couple of spikes in the months. But if you look at the malware, it happens in different period of the month. And there is also a large spike when there is attack going on. So this is a trend for November. So in this scenario, we again see the malware spike in different day of the month, and we also see 2-3 spikes for virus. So basically what the trend is, one type of attack is happening with the malware. Basically the type is Malgen X, IX. And also this is actually this is latex malware type during that particular period. So the attacker attacks with this type of malware because maybe the antivirus is not passed, the security system is not passed for that. So they have high likely to get undetected. Okay, so that's why they chose this type of malware to attack. And we also see other type of attack that uses a different type of viruses to launch the attack against the system. So this is similar, this is for December. And in January, we basically mostly see Malgen IX type of attack. We do not see too much about others. And in February, as we saw before, February has the highest of virus. So we had a new virus on February, which is a Trojan Fujigen. So that attack went on in February, at the end of February. So causing the virus attack to go much up compared to others in February. Okay, so this is, if you compare the reputation score between days, we see Malgen KB minus 5.9, IX 5.9. So you see so this is the, because of these scores, these malware attacks were blocked by default. Okay, and as you can see, initially in some cases we saw a reputation score of 5, but after further detection, so when the malware is detected, so we see the score went down after, as the attack went on for more time. Okay, so as we can see, as we see more attacks of the similar type, the reputation score goes down further. One interesting thing was that for the JJ part, so you see that initially we saw some score that was 9.5, which is very good reputation with very high reputation score, and this type of thing are supposed to be allowed by default. Okay, so this probably happened when one of the reputed server was compromised, and it was allowed for some cases, but when in some cases when the random traffic was analyzed, so it was detected that there is a malware, and the reputation, consequently the reputation went down, and it was blocked by the system. So let's look at geolocation of the malware sources. So this is, based on the IP address. So we should note that the IP attacker could have faked the IP address. So if it is fake, then we do not know the actual IP locations. But assuming the IP address was not faked by the attacker, so we see attacks from all over the world. We see attacks from Europe region, from different countries. We see attacks from US, from different states. We see some attacks from China, different regions of China, and also some attacks from India and also in Africa as well. So if you rank this, so this is from October, this is from November to January. So we basically see similar trends. So there's Europe locations, there is also the US locations, and also the China locations are mostly where the attack originates from. So this is for the whole 5-month period. So the color actually signifies the attack volume as well. So the more red, it means the more attacks comes from those regions. So US, we see, very red. China, Germany, so that means the major attacks actually came from those locations. We saw some attacks came from Canada or Russia as well, and some moderate type of attacks come from other countries as well. So if you rank the countries, so we see most of the attacks comes from like 4 or 5 countries. So China, in October it was France, then we have China, United States, and Russia, and also Germany. So the most of the attacks comes from this region, and there's also attacks from other countries here. If you look at the other periods, we see there's also attacks from Germany, China, US, Russia. So these, like European countries and Russia, United States, and China, these are the major attack originator to different systems, according to our findings. Okay, so we actually collected more data as well. We're also collecting data right now, but we did not analyze the data further. So our technical team will also do further analysis after, over a period of time. So to conclude, based on this real deployment that we did on CESS, so what we identified is that it is very challenging to provide security service based on cloud because of the large infrastructure requirements. You need a very large infrastructure. So if you want to provide security service to tens or 50 large institutions like universities, so you need an infrastructure like the cloud infrastructure is large that it can handle the traffic of that. Okay, so that is a big challenge, how your infrastructure supports that. And also there is also, I think, software issues. Even though we are using like very reputed software like Cisco, it still had a lot of issues in terms of managing the traffic, in terms of giving correct outputs and saving the data. So these are, real challenges for big traffic. But if you want to give like moderate support to small institutions, I think it's quite doable. But for large cases, I think we have to think a lot about how scalable it is. And from our analysis, we can also see the CESS system can provide additional security. Okay, some of you, if you're not in the first series of the workshop, so we propose CESS as an additional layer of security. We did not say it will provide the ultimate security. So we said, okay, we need an end user security as well. We need institutional level security as well. But CESS, because it is at the gate of the system, so it can provide additional security. And we showed, as you saw, it can block attack at the beginning of the session. So those attacks are blocked and it will not go further. It will not reach the users, targeted users. So that means by blocking the attacks at the gate level using CESS, we can provide additional security. Okay, but as I said before, some of the traffic will be bypassed because the reputation score could be higher, or it could be for new malwares, it will not be detected. So like the zero-day attacks. So in those cases, we still will be needing securities at the end user device as well. So our analysis, to summarize, our analysis shows there is 33% of the data is actually attacked on average if you look at the data in several months. And the attack escalated from 11% to 46% in 4 months. So which maybe because it becomes more known to internet, but for some reason that we see a lot of escalation of attacks in over a period of time. We also see almost 75% of the attack is actually originate from 4 specific countries. And we also find that the botnet detection count is very low. So the main reason for this is not that the botnet attack is not happening. I think, or what we think is that it's very difficult to detect botnet because of the characteristics of the botnet. So using this type of software, it could be very difficult to detect botnet with high accuracy. Okay, so I think that's all I have. If there is any question, I'll be happy to address those.